Fine. So let's import the NumPy and pandas and import the Titanic data set and print the head method. So head method is basically going to use top 5 rows. So here you can see passenger ID, survived, P class and a different column names. So in this data set, I'm sure many of you have heard about the Titanic cruise that went, had a mishap, right? So long ago. So this data set is all about those passengers who were sailing in that particular cruise, right? So their passenger IDs and this survived is basically either they survived or dead. 0 is for survived, 1 is for dead, right? So, sorry, 0 is for dead, 1 is for survived, right? And in which class they were in the cruise, third class or first class or second class, things like that, and their name and the sex and their age. And this is a SIB-SP is basically a siblings. Do they have siblings and things like that? And PARCS, the PARS is basically a guardian or a parents, right? And their ticket number and how much they paid and which cabin number and from where they have started their journey, right? Embarked. So this cabin is nothing but like how we have cabin in our railway and all, right? So same thing in the cruise also, there are some different cabins. So whichever cabin they were in, so those cabins have been displayed here, right? This is basically Titanic dataset information. Now let's look into the identifying the unique values. So I'm talking about a survived. So how many classes are there? 0 and 1. So but we don't know because it is showing 0, 1 within this 5 rows. There may be other numbers also, right? But how do I know that how many unique values are there? So how do I check the unique values? So what I am going to do, I am going to select that particular, give me a second. I'm going to select this particular column from this data set. This is the column and I will say dot unique. Dot unique. So this is going to give me unique values. Unique values, okay? 0 and 1. There are only 2 categories, only 2 classes, 0 and 1. So this is how I will be able to find any column, unique values, any column, right? So fine. Now what we will do, we have a 0 and 1. So if I want to rename them, if I want to give a different name, so 0 and 1, it is basically difficult to remember whether 0 is dead or 0 is survived, right? So it's better to give a direct name for that. There are other values, but using pandas method, we'll try to understand. So 0 and 1 are what? They are categories. 0 is one category, 1 is another category, right? So what we are going to do, we are going to check the categories. So yes, pandas dot categorical, this is the method. Categorical is the method. There I am going to use this particular column. From this data set, I am selecting the particular column. So whatever the categories available in the survived, which is 0 and 1, will be stored here. 0 and 1 will be stored here, right? So fine, it has a 0 and 1. Now I will take that 0 and 1. So it will have a 0 and 1. Then I will say dot rename underscore categories. So I'm saying that, okay, I have 0 and 1. So I wanted to rename those categories. This is one method in the pandas, rename underscore categories. So dead will be assigned to 0, survived will be renamed to, 1 will be renamed to survived. So since I have only 2 categories, I am giving 2 names, as simple as that. So 0 and 1, right? So yes, those will be stored here. So dead, now dead, my new object will have dead and survived. So I will take that and I will say dot describe. What it is going to give? this describe method will look into that. Let's execute this. So it is going to give me some kind of a stats. What is that stats? So first of all, we had a 0 and 1, now we convert it to dead and survived. So it is giving me a counts of how many people or passengers died. 549 passengers died and 342 passengers survived in that cruise. So this is some kind of a stats. So how do I get that? Using dot describe method. And this is frequency is basically the ratio. 61% passengers died and 38% or 39% passengers survived. So this kind of information I will be able to get, right? So here what we did, we tried to rename those categories. Let me repeat once again. Otherwise, we have one more example. We'll look into that. If you had a difficulty in understanding in the first instance, we will look into one more example. Same concept. So here, you need to understand whenever you are going to rename the categories, you need to pick such columns which are a categorical data. When I say categorical data, I will have only limited options like a dead or survived, male or female, first class, second class, third class, only 3 classes or 4 classes, 5 classes. There won't be anything like a 0.5. I will not have any 1.5 class. Either I will have 1 or a 2 or a 3 or a 4. Fine. Now what I'm going to do, I'm going to take this pd.categorical. Then I'm going to look into the number of classes, P class, right? P class, passenger class. So we don't know whether it is having 1 and 3 or we don't know how many classes are there. So how do I check? Again, I'm going to change this survive to P class, right? So you can change it and you can get that one. So let's do that one. So I'm just going to copy this and I will just keep it here, paste, and I will just say P class, P class. Then I will run this cell. Then yes, we got 3, 1, 2. It means that there are only 3 classes, first class, second class, and third class. So it is showing the 3, 1, 2 because the data is like this. Okay, if you look into this, 3, 1, and next one is a 2 somewhere. It is following this order, right? So it is in different order, but we were expecting 1, 2, 3, but it is showing a 3, 1, 2. That is fine. At least we know that how many classes are there. 3 classes are there. Now what I will do, how do I rename these categories? First of all, I will use pandas.categorical and I will define my particular column in that data set. Then I will say ordered equal to true. Why I am saying order equal to true? Because this is in different order. So irrespective of which order, I wanted to set it in proper order, that is 1, 2, and 3. Why I want to do that? Because I wanted to rename these categories like a class 1, class 2, and class 3. If I leave just like this, so what happens? Class 1 will be assigned to 3, class 2 will be assigned to 1, class 3 will be assigned to 2. I mean, it will be renamed differently, right? So yeah, to make sure that I rename properly and give the proper name, so I'm going to set it to order equal to true. So now it will be in this order. So now I will take this, it will have 1, 2, 3. So 1, 2, 3, same object name dot rename underscore categories. So class 1 will be replaced, class 2 will be replaced with class 2, 3 will be replaced with class 3, right? So then I will say dot describe to check the stats of different class passengers. So it says in class 1 category, in class 1 we had 216 passengers. In class 2, there were 184 passengers, and in class 3, there were 491 passengers, and this is the ratio. So we'll get to know that, okay, so in this particular class, how many passengers were sailing. So that is basically, I will be able to, that kind of information I will be able to see here. Fine. So what we did, we kind of did some kind of a manipulation. So converted 1, 2, 3 to the name, this different name, so that anybody can understand this. Right? We are manipulating some data here. Now, yes, if I want to assign, right, we have manipulated, yes, we have seen, but I wanted to assign this to main data set. Instead of a 3, I wanted to keep it as a class 3. So this one, class 1. So how will I be able to change it? So let's look into that. So this guy, new underscore p class, is having what? Class 1, class 2, class 3. I will take that, all those data, and I will reassign to this particular column. Here we had 1, 3, 2, 1, 3, right? So these new names I'm going to reassign. So let's reassign. Now let's check whether it has changed or not. So I'm just saying dot head method. So now you can see there was 3, 1, 3, 1, 3 have been changed to class 3, class 1, and so on and so forth. So this way I can able to manipulate any particular column, categorical column, I would say. So you can also go ahead and change this survived to this particular column with, dead and survived names. Same concept. Fine, that's about that. Then let's look into cabin. So how many cabins we have? Unique cabins. So yes, you can select that particular column and check the unique values. Same old procedure. So let's check that. So we have these many unique cabins. Unique one. Right? So there are some cabins are missing, NaN. So those also have been printed here. So we don't know the count of those NaNs, because all are NaNs, it is going to show you only one time, because we are trying to fetch unique cabins. All right. See, we have here, the idea is basically, we have C85, C123, E046, J6, right? So basically, we don't want these numbers. Suppose I wanted to see only, I wanted to know only C, A, B, D. So we have some numbers along with this cabin. I would say category C. A1, 2, 3, B4, 5, 6. So like that we don't want these data. I want to keep only A or B or C or D. The very first character, because these numbers really doesn't matter. Right? So let's look into this way. Suppose say one of your friend or a relatives coming from some any location, right? So Bangalore to Delhi or Delhi to Mumbai, wherever, and you are at the receiving end, and you went to the say railway station, and they will say that, okay, I am into first AC, right? Or I would say I'm into S9, something. So there are different, I would say, compartments or bogie name, whatever the names they give, S1, S2, and things like that, right? So basically, S is one, and first class AC, 2 AC, 3 tier AC, things like that. So they really don't care about the seat number, right? They really don't care about what exactly inside. So all you want is basically in which bogie or in which whatever you call it. Here they call it a cabin. I don't exactly remember what is the name for that. I hope you are understanding what I'm saying. so that you can go there and directly, stand nearby that particular uh, place where supposed to halt, right, that train. So here what I'm trying to say, we are not worried about these numbers. All I want is only the first character. So how will I fetch that one? How can I eliminate these extra numbers? So this is one example, right? You may get into such kind of a situations where you need to extract the starting character, be it is alphabets or numerics, whatever it is, right? So if you want to extract out of these 3 letters or 4 letters or 5 letters, so you want only the very first letter or the character. So how will I do that? So what I'm going to do, first I will take this cabin data and I will convert that into string. I will convert that into string. So the whole thing, because it's a mixed data type, right? D is a string and 30 is an integer. So we wanted to keep all the information, all the data in one data type. That is, so I will convert that into string. Without that also you can do it, not a problem. So it's always better to keep in one data type, so that we know that which data type we are dealing with, right? Just to make sure. Fine, I'm going to convert that into data type string, so I can do it using a as type. So all those things are stored here. Nothing has changed, only data type has been changed to string. Now what I'm going to do, please listen carefully. So let me take one example. Let's take a C50, C50. Okay? This piece of code we'll try to understand. So this car cabin will have all this information. First thing, okay? I will keep it here. So we have multiple logic here within the same piece of code here. So first we need to understand what code will work first. So first it is going to look into this for loop. So here I'm saying for every cabin in this car underscore cabin. Car underscore cabin is having all this information. So for every cabin means what it is going to do, it is going to pick first, very first. Here let me go little up here. Okay. So first what it is going to do, first time it is going to pick this NAN. Okay, first time. Then what happens, this cabin will be passed here, NAN will be passed here. So this again will be having this kind of indexes, index positions. So here I'm going to pick the 0th index. So only n will be picked. Only n will be picked. And the next time again it will go back here. Then the next cabin, this time C85, C85. Then again this cabin will go back. And here I'm going to fetch only the 0th index, 0, 1 and 2, right? So I'm going to pick only the 0th index. So earlier we had n, now this time C will be stored. Next time again it will go back here and it will go to the next item C1, 2, 3. So here again we have 0, 1, 2, 3 index, right? So again it will go back and pick the 0th index, again C. So similarly, it will keep continuing until the last element. Until the last element. So what is happening here? Every time it is going to fetch the starting character because of this index. Right? The whole thing I am just giving this square box. So I'm covering this whole logic with a square box. So that is basically what we call list comprehension. The name is list comprehension. So what exactly list comprehension? Creating a list using another set of string or a list. So it is going to return some data, right? So whole thing I am just keeping that inside the list and converting it into an array, right? So this way I will be able to fetch very first character. If you want the second character, a third character, what you need to do? You need to change this index position according to your need, right? So the whole data will be stored. The very first letter or the first character will be stored in this new cabin. So now we are falling back onto the same concept like pd dot categorical. pd dot categorical. So here all the categories will be there. C, D, A, B, all these first characters. So all will be stored in this new cabin and I'm passing here. The same concept what we have seen. And I'm saying a dot describe. Now let's look into that. See that this is what we have fetched through that cabin data. And now we will be able to understand in cabin A, there were 15 passengers. In cabin B, there were 47 passengers. Similarly, different cabins and count of those passengers. This N is basically NAN data. So here basically we can say that, yeah, these are the missing data, missing cabin names. So yes, there are 687 passengers. For those cabin numbers or names are missing. So this is just kind of an analysis. All right. So that is what basically we are trying to see here, the different cabins and count of passenger in particular cabin. All right. Now what I'm going to do, I'm going to take this new cabin and I will reassign. So earlier what we had, if you go back and check, give me a second. Earlier we have this kind of a names, cabin names, C85, NAN, C123. So when I reassign this, and I will print the head method, so you can see our cabin names have been changed to N, C. The very first character I am replacing with very first character. Right. So here this is one way of doing a data manipulation. So according to your need, you need to manipulate. If you want the second character, you fetch that way and assign it. Right. Here we had some numbers and we converted into some names. So based on the requirement, you will be able to manipulate the data. Now, if you look into the age, so there are some NANs. As of now, it is showing one NAN, but we don't know how many NANs present in that. And I wanted to fetch all the passengers whose age is missing. Whose age is missing. So for that, what I'm going to do? So we know the methods, but we just need to apply properly. What we will do, we will use this numpy.where, np.where. What this guy will do? This guy is going to get the index position of what? Index position of missing values or NANs in simple we can say. How do I get that? So for that I need to write simple code here. So what I need to do, I first basically I'm looking into the age column, right? Select your age column. Then check, is it null? Is null method. We have seen that is null method. And I'm checking wherever it is NAN. So I'm setting it to true. True means if this guy is equal to NAN, then it will return true. Right? Here we don't have, so it will return false. So in this case, it is null. So yes, it is going to return you true. So I'm checking each and every element whether it is null. I'm asking whether it is a null. Okay, is it a null? Is it a null? Is it null? Is it null? every element will be checked. If it is null, it will return the true. Whenever it returns true, right? So this numpy.where will record the index position. Suppose this is NaN, it will record 5 because this is the index position. Similarly, I have NaNs at different locations, different positions, right? So those numbers will be recorded here. Only the index positions, not the entire data. Remember that. Not the entire data. So let's execute this. So you can see 5, right? We have seen already that one, right? 5. Where is this? This guy. The index position is 5. Yes, it is returned. We have seen that np.where, right? Similarly, all these guys are basically what? The index position where age data is missing. But how do I know the entire details? Passenger details whose age is missing. Only age is missing, but still I want to know their passenger ID, whether it's survived or dead, which class, name of that passenger, male or female. There are many details, right? How do I fetch that? With this, it is not going to help. And I don't want to scroll up and down and see all these index positions. So in that case, what I'm going to do, so these are all what? These are all indexes, right? Remember that, index position. So I will take this index position, all this data, then I'm going to say in this data set, you locate .loc, locate. What I need to locate? Yes, these are the indexes. I have to locate the data for these indexes. That is basically what? Locate. Locating, here I'm going to give the index position. Index position. So let's print this. There are 177 rows which had NaNs, right? 177 rows, and you see this age column, it will show all NaNs only because it fetched all the NaNs. So how many rows we have? 177 rows. You will get that details as well, right? So yes, you got this, and whatever you want to do with this age guy, whether you want to replace with some data, some numbers, right? It's up to you how you want to treat that. So data cleaning part, and we have seen, right? So during the data cleaning, we have seen when to remove and what kind of a data we need to update, how we can update, how we can fill it. So you can apply those techniques and you can fill in if you want to fill in, right? Yes, in the upcoming sessions, we'll see some advanced techniques to deal with these NaNs, right? Similarly, I wanted to see the maximum fare. What is the maximum fare? Right? So again, I'm going to use numpy.where. So this is our fare column, right? We have a fare column. 1 second. We have a fare column, this guy. So I'm checking each and every element, this element, against whether it is equal to maximum fare. So let's look into this. This is very clear. This is each and every element it is going to check. But this side, so I'm comparing with some other data, right? What is that other data? That other data, I'm saying using this max function, max. So I want maximum data, or the maximum number in this particular column, the same column. What this guy will do, it will search through entire column and it will fetch the maximum fare in one shot. In one shot, it is going to get the maximum fare. Yes, I could have, fetched that way. But here what I'm trying to do, I'm trying to fetch all those passengers, whoever paid the maximum fare. So that is why we are using this. If I just say max underscore, sorry, only this code, what it will give? It will give the maximum fare. Let's say $69.55 is the maximum fare. It will just give this fare. But what I want to achieve, I want to check all those passengers who paid the maximum fare. So that's why I'm checking. So it will take this data and compare against the maximum fare. If it is equal to that, yes, it is going to store that particular index, right? So let's execute this. So there are 3 passengers. These are the index numbers. There are 3 passengers who paid maximum fare. So let's look into that. The same concept, these are the indexes, and I will say dot location or dot LOC. Whenever you have a LOC, make sure that you pass the index position. If you want to select any particular data, any particular row, yes, you can go ahead and say dot LOC and index number. So that will fetch any particular row, whatever the row you want to access. If you know the index position, just give that index position. Yes, so let's execute 258, 258, 679 and 737. So yes, I'm able to fetch all those passengers who paid maximum fare. So if you look into the fare column, right, all are same only. So this way I will be able to fetch those passenger data who paid maximum fare. So condition can be different. Here I have taken a fare, right? Maybe you can check for a maximum age, highest age, right? Or a P class. So you just need to play around with the column names, right? Whenever you have a maximum, make sure that your column is having a numbers, integers or a float, right? So because for the text and all, we cannot, it doesn't make any sense, right? Maximum text. It doesn't make any sense, whether A is big or B is big. We don't have that kind of a concept here. Okay? Yeah, you need to make sure whenever you are using max or min, average, you need to have a numerical data, right? Fine. So when you suppose if the requirement is to fetch all the passengers who paid maximum fare, you can use this and store this data and send it to whoever is looking for this data, right? And the last, find the family who has highest members. Find the family who has highest members in this particular cruise. How do I find the highest family members? So if you remember, I was mentioning this is a sibling and this column is basically guardian or parents. So when we have a sibling and a parents or guardian, so obviously they are basically they are part of a family, right? So what I am going to do, I am going to add both of them. So here I am creating a new column, family. So I will just add all of them, both the column data I'm going to add. Select siblings column plus select your guardian column or parents. So here 0 plus 0, it is going to give me 0. Right? Wherever we have a data, so it is going to club both of them and it will add, right? So fine, family data I will have like here I will have a 0 and for this I will have 1 and 0 like that, 2, 3, 0, 5, 2. Some numbers I will get, right, in the family column after adding both sibling and parents column data. So now what I'm going to do, so the same concept I'm going to use. Titanic family column, this column equal to maximum family, maximum number from this particular column. So again it is going to search through the entire column and wherever it finds the maximum number it will bring, let's say 10, right? It is going to bring 10. Then first time it will check whether 0 is equal to 10, no. Then it will go to the next one, whether 1 is equal to 10, no. Somewhere you will have a 10, then it will come to this position, then it will check whether 10 is equal to 10, yes. Then corresponding, using this dot and p where, right, corresponding index location will be stored here again. And same concept we are applying location. Dataset dot loc index position, then run it, you will see the family members, you see all are 10. They all belongs to same family. And how do I make sure that? How do I evaluate? Yes, we can look into other data. If you look into embarked, right, all are embarked from this particular station, whatever it is. Let's not worry about name here. And they have paid same price, right? Because you are all going in the group, all our family members, obviously you will pay the same price, and the ticket number is also same. Now, because one person, maybe one person filled the form, he did not enter any, any family member's age, so all are missing. And if you look into the name, you look into this, maybe its last name, Seg, and Seg. It proves that, okay, they all belongs to same family. So yes, it is pretty clear that yes. So this is the maximum. This family is having maximum members in that particular clause, and all are selling in the same class. The class is 3, and they all died. All right, and these are all the real data. Okay, it's not something cooked up. These are the real data, and these are the real names, right? So this way I will be able to fetch, and I will keep only this information in a new data set, and I will work on it for different reasons.